So, guys, we're going to be talking about conditional probability. And here is the formal definition. And I know it looks a little daunting. Okay. It's defined in terms of sets. So don't worry too much. Conditional probability informally simply means we're going to add a condition to the sample space, and the sample space will shrink and become a little smaller. And we're going to work with this sample space, the new smaller sample space, and find probabilities based on that. So it's not as bad. Here's the formal definition, but it won't make a lot of sense. But when we do a few examples, things will look better, I assure you. So the examples I'm going to be used are from your book, but more importantly, they are very generic. Most books have those. Let's see. Now let's grab. We're going to do a couple of problems here. They're not that difficult. That's good news. So here is an example. 56 students are majoring in the following three disciplines. You are picking a student at random. Generally, when we hear the word given that, generally problems when we say given that she's a female or given that it's a math major, we are thinking about conditional probability. And we're going to do an example, so it'll make more sense. So I have a set of data. I have astronomy students. 8 of them are female, 7 of them are male, a total of 15. I have biology students. 9 of them are females, 11 of them are males, altogether 20. Chemistry students, 6 females, 15 males, 21. And how many females do I have? 23. If you add 8 to 9 to 6, how many males do I have? 7, 11, 15. Now, let's look at some of the questions. If I give you this scenario and do a regular problem, you have 56 students. What's the probability of getting a female astronomy major? Okay, well, that's easy. Probability of getting a female and astronomy. Probability of getting a female and astronomy. Well, it's really not that bad. There are 8 female astronomy majors out of 56, so the answer will be 8 over 56 is equal to 4 over 2 over 56, 14, I think. Oh, I can do even better. 1/7. Okay. The problem, this is not conditional probability. Okay. Female astronomy major. What if I want to find what's the probability of getting a chemistry major, regardless of the gender? How many chemistry majors are there? That would be probability of C. There are 21 chemistry majors, and there are 56 students. Out of all the students, 21 of them are chemistry majors. And I don't think you can cancel. Oh, you can divide both by 7. If you divide this top by 7, you're going to get 3. If you divide the bottom by 7, you're going to get 8. So the probability of getting a chemistry major, if you have 56 students, some of them are astronomy majors, some of them are biology majors, some of them are chemistry majors, is 3 over 8. Now, this is not a conditional probability problem or question. Now we're going to ask some conditional probability questions. Okay. Now I have the same scenario. Okay. What's the probability of getting, okay, let's write it down very carefully. Find what is the probability of getting uh, an astronomy major, given that she is female. Now, this part, given that, tells me it's a conditional probability question. Very important. Okay, given that, very important. Once I say given that she's a female, that means I'm only looking at the females. I'm not looking at this whole sample space. My sample space shrunk to this. And then you can answer the question. So you're only discussing the females. You're only interested in the females. So given that she is female, so what's the probability of getting an astronomy major given that the person you're talking about is a female? Well, there are 23 females and 8 of them astronomy majors. So it's going to be 8 over 23. Done. That's the answer. That's what we mean by conditional probability. It's not a very difficult concept. We're going to do 2 or 3 other problems. Another thing to keep in mind, sometime the word given will not be written and give instead of that, they're going to write, just put a vertical line. Okay. So this given that and vertical line, they represent the same thing. All right, let's do one more. I'm going to change it around and you're going to see how that changes everything. Okay, I don't need that. Given that tells me it's a conditional probability question, conditional. There is a condition on your sample space. What's the probability of getting a female getting a female, given that she's a chemistry major, or he or she, given that he or she is a chemistry major, chemistry major. Now, again, the given that part tells me how to shrink the sample space. Now, given that he or she is a chemistry major tells me I'm only interested in the chemistry majors. I don't care about any other majors. I'm going to put it here, block this off. That's all I care about. Okay. So once we say, given that the person you're finding or finding the probability of is given that the person is a chemistry major, tells you that you don't care about anyone else, you only focus on chemistry majors. What's the probability that chemistry major will be a female? Well, that's not that difficult. It's going to be there are 6 females, 21. And now you can divide both top and bottom by 3. You're going to get 2 over 7. I hope that makes sense. Okay, I'm going to do 2 or 3 other problems. Once again, in conditional probability, we add a condition to the sample space and that shrinks the sample space. Other than that, everything is the same. And there are many more examples here, okay? Given that. So take a look. All right, this is an interesting problem. Let's talk about it a little bit. It is also a conditional probability problem. So let me bring the text and the picture here. So I have a bunch of cards, and some of the cards are blue, some of the cards are light purple, some of the cards are pink, and there are letters on each card. Let's see what the question says. I randomly draw a tile from above without looking. What's the probability I got a tile with the letter A on it, given that I got a blue tile? The moment I say I got a blue tile, okay, by the way, I'm going to say these are A and B. These 2 are blue tiles. I'm going to say A, P, Q, W. These are light purple tiles. You can say purple. And A, C, C, Q, C, P, X, these are pink tiles, and the rest of them are green. So the moment I say, given that I got a blue tile, I'm focusing my attention on just these two tiles, A and B. What's the probability of getting an A? If you got a blue tile, well, how many blue tiles are there? Two. How many of them contain A? Only one. The answer is half. So it's really not that bad. Okay? Let me do one more problem. Same data set, but now we're talking about the pink tiles. So once again, given that I got a pink tile, that means I'm only interested in these tiles. I don't care about the whole sample space. I only care about these 7 tiles. So my focus is on the 7 tiles. All right. Now, what's the probability of getting a letter X given that I got a pink tile? Again, it's a conditional probability problem, given that means I shrunk my sample space. And I'm going to say, well, that's not too difficult. The denominator has to be 7, and there's only one X. 1 over 7. That's my answer. And you can try these. They're very repetitive. Let's see what else is going on in our notes. Okay, I'm going to do this problem. It's an interesting problem from your text, or every text has a problem like this, so to speak. So let's do this one. It's a conditional probability problem, but we have done problems like this. So I have a bowl that has 2 blue marbles and 3 white marbles. One marble is drawn first, and the second marble is drawn without replacement. It's really like um, having 2 containers. I only have one container. And let me make a nice table. Okay, so my marbles are blue. Okay, let me add some more. Blue. Let me make it even better. Make this a little bigger. So I'm just going to create my sample space first. Okay. My container contains blue, blue, white, white, and white. And I'm going to list them here too. That's my second draw. Blue, blue, white, white, white. I'm going to draw a marble. I'm going to record its color. Then I am going to draw a second marble. Now remember, if you get the first blue, you're not going to get this first blue again because you're not putting it back because it is with replacement. It is with replacement. Okay, so you're putting it back. Okay, you're putting it back. Sorry. So let's list it. So you could get BB, BB, BW, BW, BW. Let me see if I can copy paste this. Seems like it won't take it, but that's okay. BB, BB, BW, BW, BW. And here, WB, 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 WW, WW, WB, 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 sorry, WW. This should be WW as well. And WW, WW, W. I'm going to double check, so don't worry. Now that looks about right. This is my sample space, okay? Without the condition. We're going to come back to the condition, okay? Now, these problems take a little bit of time. Be aware of that. My sample space, whatever color this is, bluish green, this is my sample space without any conditions, okay? Now, it says, what is the we're doing it with replacement. Now, if this was without replacement, you would be removing this diagonal. Keep that in mind. That's the only difference. If you didn't replace it and it was without replacement, this diagonal shouldn't have existed. It wouldn't exist. Now, what's the probability of getting two blue marbles? There are four cases where you have two blue marbles. And altogether, if you count all the boxes inside this green rectangle, you're going to get 25. So the answer is going to be, answer to A is going to be 4 over 25. Okay. What's B? Both marbles are blue, given that the first marble is blue. Given the moment they say given that the first marble is blue, it becomes a conditional probability question. And the cases where the first marble is blue are here. Remember, a conditional probability reduces, changes your condition. Let me change the color to yellow. Okay, I am only focused right now on this rectangle, not the whole sample space, not the whole thing, only this, because these are the cases where the first marble is blue. What do they want? Both marbles are blue. Given that the first marble is blue means the denominator has to be 10. If you count all the little boxes, you're going to get 10. You're going to get 10. Both marbles are blue, 4 out of 10. 2/5. Done. Again, I can give you the same question without replacement. You don't put the first marble back, then you won't have this diagonal. Everything else will be exactly the same. It's really not that bad. Let's see what else is going on in our notes. So here is another example without replacement. And take a look, it's in the notes. It's the same problem, really. And I'm doing it in 3 different ways, but if you do it without replacement, you won't have the diagonal. And if they say the first marble is blue, you'll only focus on the first 2 lines. So the examples are here. Take a look. These notes are available. They're um, in your online folders. So I hope that helps, guys.